Okay, so I've got an equation on the board here. N2O4 is a gas, in equilibrium with two NO2s as a gas. The delta H of reaction at standard conditions is plus 57.9 kilojoules per mole. The delta S at standard conditions is plus 177 joules per mole Kelvin. Okay, so our first job is to calculate delta G 0 for the reaction. We got our H and S. That should be pretty easy to do. We'll calculate this, and then we'll recalculate it at a different temperature and see how it changes. So delta G 0 for the reaction is delta H 0 for the reaction minus T delta S 0 for the reaction. Standard conditions, T is 298, right? So just literally plug in and chug our numbers. So delta H for the reaction is plus 57.9 kilojoules per mole minus 298, because it's at standard conditions, 298 Kelvin, times our enthalpy has to be in kilojoules per mole, 0.177 kilojoules per mole Kelvin. 0.177 kilojoules per mole Kelvin down here. So delta G at standard conditions, 57.9 minus 298 times 0.177 plus 5.154. Kilojoules per mole. Delta G is positive, so it's not spontaneous at standard conditions. Delta G is not very big, so we wouldn't expect a lot of either reactant or product necessarily to be made. It's close to equilibrium as it is at standard conditions. So now we're going to rework this problem at a new temperature. So we're going to rework it at, I chose a temperature of 398 Kelvin. So we're going to raise the temperature 100 degrees. And we're going to rework the problem. Now we're calculating delta G without the 0 symbol. So not at standard conditions anymore. Our delta H plus 57.9. Remember, like I mentioned in a previous video, we can work these at different temperatures, but we have to recognize that H and S may not necessarily be completely constant as temperature changes. But this will get us awfully close to the right ballpark. So minus T, which is 398 K this time. S was 0.177 kilojoules per mole Kelvin. So we run these numbers through. 57.9 minus 398 times 0.177. So delta G at this temperature is minus 12.5. So it flipped spontaneity in that 100 degrees. It went from being non-spontaneous at standard conditions to spontaneous at this temperature. So let's figure out at what temperature that changed. So at what temperature did the sign on delta G change? You could have also been asked at what temperature does it become spontaneous, or what temperature does spontaneity flip? All those things mean the same thing. And the temperature for that, we saw that in a different video, but we take our equation here. When delta G is 0, these two terms are equal to each other, and out of that, we got that the temperature was delta H over delta S. So in our case, delta H was 57.9 kilojoules per mole over 0.177 kilojoules per mole Kelvin. So the temperature at which it flips, 57.9 divided by 0.177 at 327.1. That's when we estimate that the spontaneity flips. So at standard conditions at 298, it was non-spontaneous. At 398, it was spontaneous because we had passed this temperature. Okay? Now our next video is going to keep working with this same equation, the same setup, the N2O4 becoming two NO2s. But now we're going to start to feed it into the equilibrium process. We got Q and we've got S to go with that.